Concrete beam, Video 5, Design Part 2. If one wishes to optimize the length of the bars, the graphical tool curtailing can be used. Then an image is displayed showing the bars colored black, blue, and possibly also green. The black bars are not allowed to curtail, and the blue ones are situated in the same layer as these. When a new layer begins, it's colored green in order to make it easier to curtail layer-wise if desired. The blue curve shown corresponds to the tension force distribution, and the red to the tension curve, taking into account the effect of inclined cracks. To obtain a required anchorage, the black coverage line must be situated outside the red curve. For example, if one wants to curtail the bottom reinforcement for span 2 as much as possible, one should snap one of the green bars in the second layer and drag it until the coverage line is a tangent to the red curve, first on one side and then on the other. This procedure is then repeated with the blue bars in layer 1. It is the user's responsibility to make sure that the covering line does not fall inside the red curve. The curtailment is performed layer by layer, which is the default choice as seen earlier, but can also be made bar by bar if desired. This can also be changed with the tools curtailing layer by layer and curtailing bar by bar. With the tool buttons Geometry and Loads, Moment and Shear Force, Reinforcement Layout, and curtailing, one can quickly jump between input and different results. If we now go back to program mode Reinforcement Layout, it can be seen that the 6 bars in layer 1 has been reduced to 5510 mm and the 2 bars in layer 2 to 3830 mm compared to the original 8000 mm. For the bottom reinforcement at span 2, it is thus possible to save about 24 meter reinforcement if considered to be profitable in relation to a somewhat more complicated application. The design results can also be presented as tables. Under the option Table, Design, 2 choices are available: bending reinforcement and shear reinforcement. With the option Bending Reinforcement, information about selected and required bending reinforcement, effective height, and if minimum reinforcement is decisive or not are presented at different points. With the option Shear Reinforcement, data for calculating the shear reinforcement is presented. If we look at span 2, we see the 5 areas dividing the span. Besides diameter and CC distances, the design shear force VSD is shown for each area. The concrete capacity is 0 because the truss method is used in Eurocode, and then shear reinforcement is required to obtain any capacity at all, unlike for the addition method. It can be seen that for area 3, minimum reinforcement becomes decisive. Finally, it's checked that the maximum shear force in each area, Vmax, does not exceed the maximum capacity, VRD max. The ultimate limit state calculation is now completed, and the next step is to examine the beam also in the serviceability limit state regarding crack widths and deflections.